One serving of tomato soup contains 100 calories and 18 grams of carbs. One slice of whole wheat bread contains 70 calories and 13 grams of carbs. How many servings of tomato soup and whole wheat bread are required to obtain 230 calories and 42 grams of carbs? So what is important to understand is that we need to keep tomato soup and whole wheat bread together in one, but also keep calories and carbs together in one. So I'll show you how to write these problems out. Tomato soup has 100 calories, so we'll have calories be X, and it also has 18 grams of carbs. And 70. Does that make sense?
Mm-hmm.
Do you see how I got that? Okay, because tomato soup has 100 calories, so this is our calorie equation, and whole wheat bread has 70 calories, so this is tomato soup and this is whole wheat bread, X, Y separated. But this whole equation will give you your total calories. And then we're going to do the same thing for carbs. So tomato soup has 18 grams of carbs, and whole wheat bread has 13 grams of carbs. And that will be your total carbs. So what it's asking us is how many servings of tomato soup and whole wheat bread are required to obtain 230 calories and 42 carbs. So what we're going to do is treat these two equations with substitution or elimination, whichever you'd like. So I'll go ahead and first put the total amount of calories, which makes sense, right? Because that was your calorie equation, right? Mm-hmm. And this is your total carbs. How many total carbs do we have? 42. So, since the board is small, I have to, sorry. Okay. Now we're going to treat it with substitution elimination. So what could we do? We could subtract negative 18 and multiply by 100. Do you see what I'm doing? I want to get rid of this X, just because I'm choosing to. You can do it the opposite. You can do it with Y if you'd like. Just make sure that they end up equaling the same thing, and one of them is positive, one of them is negative, so they get rid of each other. So then we're going to go ahead and multiply 100 by 18, which is negative, -1/8. And we know that this is going to equal the same thing, but it's going to be positive. So that's going to be, and these both have X. Now, don't forget to distribute it. So we're going to do negative 70 times negative 18, which is negative 1260. Also distribute it over here to the whole thing. You need to remember to do that. Which equals 41, negative 4140. And same thing down here. So 13 times 100 equals positive, stays the same, 1300. 42 times 100, which equals positive, since there's no negative, 4200. Okay, and now we can solve. This cancels out, which is what I wanted to do. Then we get 1300 subtracted from 1260. Because this is a negative number, it's going to be subtraction. And because this is smaller than 1300, we know it's going to be a positive number, which is 40 equals, these are two positive numbers. Or this is a negative number and a positive number. Its subtraction sign is right there. So 4,200 minus 41. 4,200 minus 4140. 4,200 is bigger than 4140, so we know it's going to be a positive number. So we can forget about the negative sign, but we do have to subtract them from one another. Forgot to put the y here. That's going to end up being 60. Now what we can do is just finish the problem like any other problem that we have, using proper things. So once you divide something on one side, you want to solve for y, correct? Because you want to solve for total amount of carbs and total amount of calories. So we want to get x and y separated so that we know the total amount for each tomato soup and for whole wheat bread. In order to solve for this problem, we need to divide by 40 to get y by itself. When we do that, we need to do it on both sides. So when you divide 60 by 40, you get 1.5. Okay? And you can go ahead and plug this back into either one of the problems to get your x. Okay. Okay. So we already got this down, so I'll go ahead and erase that and keep this bottom part. So you can keep that. So the original problems were so the original problem was 100x plus 70y, and we can just choose that one to plug it into. So because y equals 1.5, go ahead and plug it in to the original problem, not to the problem that you started solving to, because it kind of changes things up. And that total equaled 230 calories, because this is your calorie equation. Okay, so 70 multiplied by 1.5 equals 105 plus 100x. Now we're going to just solve for x, treat it like a normal problem. So subtract 105 from both sides. Get rid of this. 100x equals 230 minus 105, which is 125, and it's a positive number, divided by, we're going to do what we just did in the last problem, where we get rid of the number in front of x because it's the only thing stopping us from solving for x. So divide by 100, but when we do that, it has to be on both sides. And x equals, this crosses out, 125 divided by 100 equals 1.25. Okay, and once you get that, you can go ahead and plug it into the, either equation and see if it gives you the total amount of calories or the total amount of carbs. So now that we know that x equals 1.25 and that y equals 1.5, let's choose the opposite equation and check it and make sure those numbers are right. The other equation was 18x plus 13y equals 42. Now we're just going to plug in. Okay, we'll go ahead and multiply that out. So 18 times 1.25 equals 22.5. 13 times 1.5 equals 19.5. And then equals 42. Now, Now, if we did this correctly, it should end up equaling 42. So we'll go ahead and add that up together. 22.5 plus 19.5 equals 42. So we know that we did the work correctly. So our directions are to solve algebraically and describe the graph. So we're given these two problems, so they're separate. So let's first start with this problem. We're given x equals 3y plus 1 and 6y minus 2x equals 5. Let's first start by fixing this problem. We need to solve by using elimination or substitution, whichever you'd like. But it's better to have the problem clean by having y with y and x with x. So let's start by fixing this. And what we'll do, let's start by rewriting it. What we'll do is subtract 3y from this side, from both sides. It gets rid of this. And now you have a new equation, but equals the same. It's still the same thing. It's another way of saying it. Now we have negative 3y plus x equals 1. Okay, and that's your new equation. And we'll bring this down, the other one that you were given, which is 6y minus 2x equals 5. And now we're going to use substitution or elimination. So let's use the screen marker. When you're doing substitution or elimination, I think I'm going to do elimination because this is an easy elimination problem. When we see an opposite sign for y and an opposite sign for x, it means that you can pretty much use whichever one you want. I think for this one I'm going to use the y. So I'll multiply this whole equation by 2 because I want to cross these out, and negative 3 times 2 is negative 6, which means that these will cancel out, which is exactly what I want. But you have to multiply it by the whole equation. So our new equation will be negative 6y plus 2x equals 2. Now, we'll start from here. These are what we're going to focus on right now. So this crosses out, and this crosses out. So now we are left with 0 equals 7, which does not make sense. That is a false statement. False. So what we're going to do, this is your final answer, but it says describe the graph. And because there is no, this is what you would write on a test or an exam, because there is no solution, so the graph will be parallel. And on the graph, it would physically look like this, because they would never meet, and that is why this statement isn't true. The points never meet. Let's go ahead and move on to this one. We have 2x plus y equals 2, x minus y equals 7. Now, if you guys see this, automatically in your head, a light should be going off because this automatically crosses out. So we don't even have to do any of the actual math part. We just solve this way. So this would be 3x equals 9. And then solve like regular problems. So divided by 3 on both sides, and x equals 3. Now you're given x, but you still need to find y. So what you can do is just plug it in to either one. So 2 times 3 plus y equals 2. So that's 6 plus y equals 2. Negative 6, so you're given 6 plus y equals 2. Okay, now we want to subtract 6 on both sides. I was assuming that you guys know, but I shouldn't, so I'll explain it. And you're left with y equals negative 4. Now you officially have x and y, but you should check it. So plug it back in to either one you want. So let's just do this one, it's easier. So now we have 3 minus minus 4 equals 7. This becomes a positive, so now we're adding 3 and 4, which is 7, and your answer is correct. Now we have to describe what the graph looks like. Because our points are 3, 4, 3, negative 4, I'm sorry. We have a definite point, it's 1 point, meaning that there is only one solution, which means that your graph will meet at 1 point. It will look like this. Do you guys understand? Okay, and that is all.
Okay, this problem says, the fine for a speeding ticket in the Downward Speed Trap is $70 plus an amount that depends upon how high above the posted speed limit a driver is driving. For the first 10 miles per hour above the posted speed limit, there is an additional charge of $5 per miles per hour. For the second 10 miles per hour above the posted speed limit, there is an additional charge of $10 per miles per hour. For an area where the posted speed limit is 55 miles per hour, express the fine amount, F, as a function of the driver's speed, which is X, over the interval of 0 to 80. Okay, so first of all, we're going to start off from 0 with the interval of 0 to 55, because we're starting from 0, and then 55 is the posted speed limit. And then here, you're not going anything above the posted speed limit, so here there will be no fine. So therefore, F is going to be equal to 0 for the first interval. Okay, now the second part, we're going to start off with 55, because that is the posted speed limit. And now we're going to we're going to come up with the equation for the first 10 miles per hour above the posted speed limit, which is going to be 65. So the interval is going to be from 55 to 65. So now here, we're going to do F minus 70. And the 70, we got it from the $70 fine. And now we're going to do 5, because that's the additional charge, that's where we're getting the 5 from. And now we're going to do X minus 55, because 55 is the initial. So now we're just going to solve this and solve for X. So what we're going to do first is we're going to distribute the 5, and we get 5X minus, let me put it into your calculator, get 275. And then on this side you have F minus 70. And now we said we're trying to solve for F, so what you're going to do is add 70 to both sides. And on this side you're left with F equals 5X, and you're going to get $205. So this is going to be the equation for the interval of 55 to 65. And next, what we're going to do is we're going to come up with another equation for the other additional 10 miles per hour above the posted speed limit. So now over here, our interval is going to be from 65. And if you add the 10, you're going to get 75. So this is going to be our interval. Now we know what it's going to be for this one, for when you get to 65. So now we're going to plug in this 65 into this equation. So let's say f of 65 equals 5. And you're going to plug in 65 minus 205. And when you do 5 times 65, you get 325 minus 205 which gives you 120. Okay, and now this one, we're going to come up with our other equation again. So we're going to get F minus 120 that we just got equals the $10 charge, X minus 65, because that was our initial here. And now the same thing we did over here, we're going to solve the equation and solve for X. So we're going to distribute the X. And you're going to add 120 to both sides, which is going to give you F equals 10X minus 530. And this is your equation for the interval of 65 to 75. Okay, this problem says, the following table gives the number of calories burned as a function of body weight for a person walking for 10 minutes. So part A is asking for, find the average rate of change in the number of calories burned with respect to body weight for each of the intervals from 120 and from 150 to 200. Okay, so for the first part, we're gonna do the interval of 120 to 150. So we're gonna take the 40 calories for a person who weighs 150, and we're gonna subtract 32, because that's how many calories is for a person who weighs 120. And then in the bottom, we're gonna subtract 150 and 120. So when you subtract those, you get 8 over 30. And then you plug that into your calculator, and you get 0.267. So that's going to be 0.267 calories per pound for the first interval, which is 120 to 150. So now we're going to do the second interval of 150 to 200, which is right here. So now we're going to start off with 54. We're going to start off with the 200. So 54 minus 40. And then we're going to subtract 200 and 150. And for here, you get and then over 50. And when you plug that into your calculator, you get 0.28 calories per pound. That's for the first part. Now the second part is asking for, describe what is happening to the number of calories burned and what is happening to the average rate of change in the number of calories burned as a person's body weight increases. So here, whenever the amount of the weight goes up, the more calories are being burned, and therefore the average rate of change is increasing as well.
The magnitude m of a star is a measure of its brightness, B, given by the formula where B naught is a constant to the brightness of an average star, is m equals negative 2.5 log B over B naught. What is the magnitude of an average star with the brightness of B equals B naught? So what we're going to do first is we're going to take this equation, which is m equals negative 2.5 log B over B naught, and replace this B with this information right here. So this equation is going to become m equals negative 2.5 log B naught over B naught. This B naught over B naught can be the same as x over x or 1 over 1, which is going to be equal to 1. So now what we're going to do is we're going to make m equal negative 2.5 log of 1. When we plug this into the calculator, we get 2.5 log 1. We get 0. So the magnitude is going to equal 0. So that's the first part. Okay, so the next part of the question asks, as the brightness B increases, does the magnitude increase or decrease? Explain. Is a magnitude 2 star brighter or dimmer than a magnitude 1 star? Explain. So from our given equation, m equals negative 2.5 log b over b naught, we see that when the brightness is 1, the magnitude equals 0. So as the brightness increases, the magnitude is going to decrease. We could sub in any number for the brightness, and we're going to get a different magnitude. So I'll go ahead and do that. So m equals to negative 2.5 log, and in place of a brightness, I'll put 2. So if you plug that into the calculator, negative 2.5 log 2, we get negative 0.75. So this will be our new magnitude. So that explains why the magnitude will decrease as brightness increases. The second part of this question asks if the magnitude 2 star is brighter or dimmer than a magnitude 1 star. Well, from this, as we could see, when as the magnitude goes up, the star is going to be dimmer. So it's going to be dimmer than the magnitude 1. Next part of the question asks, the star Betelgeuse in the constellation of Orion has a magnitude of 0.5. What is the brightness in terms of B naught? So given our new magnitude, we're going to replace it with our original equation. So we're going to put 0.75 equals negative 2.5 log B over B naught. Now what we do, in order to find our brightness, we have to get rid of the 2.5. So in order to do that, we have to divide each side by negative 2.5. This is going to cancel out, and if you plug this into the calculator, you should get negative 0.3. So this would be negative 0.3, which equals log B over B naught. So this right here is going to be your new brightness, but you can't leave it in that form. So what we're going to do now is, since this is our new brightness, we're going to put it to the base of 10, because you have a log base 10. And this is going to be our exponent. So it's going to be negative 0.3. And this right here is our new brightness. The last part of the question asks, when the star goes supernova, its brightness can increase by a factor of 10 to the 8th. If Betelgeuse, which currently has a magnitude of 0.5, were to go supernova, what would its new magnitude be? So in this question, we're trying to find our new magnitude. So with our brightness from the last equation, what we have to do now is take 10 to the 8th and add it to negative 0.3, because it says that it increases by this factor. So we're going to do 10 to negative 0.3 plus 8. And with that, if you plug it into the calculator, you should get 10 to the 7.7. So our new magnitude is going to be 7.7. And that's it. This question asks, after a pollutant is dumped into a lake, each year the amount of the pollutant is reduced by 18%. Is this decline linear or exponential? Explain. So this question is going to be exponential, because after after so the amount of the pollutant is reduced by a constant rate of 18% each year. So every year it's decreasing by 18. So the second part B is asking, suppose the initial amount of the pollutant is A naught. Construct a function for the amount of the pollutant A after t years. So by the previous question, we know that this function is going to be exponential. So it's going to take the form y equals CA to the x, or in this case, t. So we know that, in order to find the decay factor, we know that 18% is going to be our decay factor. So it's going to be, A equals 0.18. Now we have to find the decay rate. In order to define the decay rate, we have to do A equals 1 minus R. So 1 minus 0.18 is going to equal 0.82. So now that we have the decay rate, we can put the function together. So it's going to equal A to the T equals A naught, which we're getting from the question, 0.82, which is our decay rate, to the T. And this right here is going to be our exponential function. So the last question asks, the lake will be safe to swim in when the amount of pollutant is reduced to 0.1 A naught. After how many years will it be safe to swim? So the first thing that we have to do is we take this from the given equation and set it equal to our previous exponential equation that we got. So 0.10 is going to be equal to 0.82 to the T. Now what we have to do is take the log of both sides. So this will be log 0.10 is equal to the log of 0.82. So if you plug into the calculator, log of 0.10 is going to equal -1, and the log of 0.82 is going to equal 0.86. So once we get this, in order to get t by itself, we have to divide both sides by -0.86. So when we do that, these cancel out, and this -1 over -0.86 is going to equal 11.628. So in 11 years, the lake will be safe to swim in.
So this problem says that Mount Everest is estimated to have a volume of 724 billion, 700 million, how do you say that?
724 billion,
100 million thousand cubic meters. A developer has bought Mount Everest and plans to grind it up and use it to fill in the Grand Canyon where his new Mall of the World is to build. A, the volume of a dump truck is approximately 64 cubic meters. How many dump trucks would it take to haul the mountain's entire volume? So what we're going to do now is we're going to write down what we initially had, which is that. And we could write it in scientific notation, so it would be 724, 7 times 10 to the 11th because it's 11 places. And then we're trying to find out, okay, it's going to be 7.247, and we're trying to find out how many dump trucks would it take. And since there's 64 cubic meters per dump truck, we're going to divide it by that. So it's divided by 64 equals, so what we would get is, okay, so we're going to do 7.247 times 10 to the 11 divided by 64, and the answer would be 1.13 10 to the 8th, and then I guess that would be how many trucks it would take. That would be how many trucks it would take to howl the mountain's entire volume. Okay, so the question says, suppose a dump truck is 38 feet long. How long would the convey of dump trucks be that is needed to haul away the mountain? Right answer in feet using 1 mile equals 5,280 feet. So bringing back from the answer that I got before, I got 1.13 times 10 to the 8th, 10 to the 8th trucks. And then, so if each one is 38 feet long, I would multiply it. And then it says, how long would the convey of the dump trucks be? And each mile, so whatever I get from this, so I would multiply that first. I would get I would get 400,294,000,000, and then it says 8 feet. So now what I would do is I would have to convert to feet, because this is miles. No, this is feet. Right? Would that be feet or mile? Feet. Okay, so that would be. Okay, so now I need to convert, which is in 1 mile there is 5,280 feet. So yeah, this would be feet. This would be miles. So then the feet would cancel out, and I would be left with 4,294,000,000 over 5,280, and my answer would be 4,294 divided by 5,280. I would get I would get 813,257.57. That's how long the dump trucks would have to be, miles, to pull away the whole mountain. So this would be your answer for that section. Okay, so the other part from the problem is asking the distance from Mount Everest to Grand Canyon is 12,000 miles. How many days would it take a dump truck traveling at 60 miles per hour to travel from Mount Everest to the Grand Canyon without stopping? So they told us that it's 12,000 miles away, and that if each dump truck would be traveling at 60 miles per hour, so what you would have to do is divide it, because it is each dump truck would be traveling at 60, so divide it. And then to make it easier, you take the 0 and the 0, you cancel that out, and you would be left with 1,200 divided by 6. So when you divide that, you get 200. And this one is miles. This one is miles per hour. So right here you would get miles per hour. and we have to convert it into days. So there is, in one day, there's 24 hours. Yeah, one day there's 24 hours. So then what you would do, this would be in hours. So then that cancels out with this one. And it's left with days. So now what you would have to do is divide 200 by 24, which is equal to 8.3 days. Because this was crossed out and you were left with with hours. So then your answer would be in hours. And then to convert it into days, because it says, the question is asking how many days. So then you would multiply, in one day there's 24 hours, so that way that can cross out and you'd be left with days, and you divide it and you get 8.3 days it would take if they were traveling at 60 miles per hour to get from Mount Everest to Grand Canyon. Okay, so the problem says to simplify the following expressions. So for part A, what I'm going to do is distribute the -2 to everything, which will equal to x to the -2, y to the 4th, z to the 6th, because x is by itself, and when you add the -2 is x to the -2, it's y to the -2, so when you multiply -2 is 4. And then z is 6 because -3 times 2 is 6. And then you distribute to the bottom, which is 2 to the -2, x to the 4th, y to the -2, and z to the -4th. So now what you're going to do is combine like terms and everything that's negative. You're going to, if something's negative on the top, you're going to put it at the bottom, and if something's negative on the bottom, you put it on the top. So since this is negative, we will put it on the top, which will equal 4.
Oh yeah.
Okay, and then here, since this is x to the -2, we're going to bring it down to make it x to the +2. And then when you combine like terms, you will get x to the 6th. And then y, it's 4 to the y and y to the -2. So we're going to bring -2 up so it can turn positive. So you would get 4, 5, 6, so y to the 6th. And then when here, since it's a negative down here, we're going to take it to the top to turn it into positive. So then you would get z to the 10th, and then that would be your answer. So for part B on this problem, what we're going to do is we're going to leave the top the same, so then it's 3x squared. I'm using a different color. So it's 3 root of 3x. Okay, so for the bottom, what we want to do is we want to simplify this. So then it would be 3 to the 24, so then that's 8 times 3. And then we want to separate these two, and what makes x to the 5th is x3 plus x squared, x cubed plus x squared. So then now what we would do is we leave the top the same. And then the bottom, what we want to do is the cube root of 8 would be equal to 2. So 2, we take that out, and since there's right here is this part is equal to x to the 5th. When we have 3, we want to take 3 out of there. So then it would equal to 2x cubed, and we leave inside the 3x squared. Take out the x, okay, and so then that would be equal to, and then this cancels out, since it is the same, would be equal to 1 over 2x, and that would be your final answer. For this part, there's no, it's 2 square root of 32 plus 3 square root of 8 minus 4 to square root of 18. And all these numbers inside of the square roots cannot be square rooted. They don't have any square roots. So what we would have to do is find 2 numbers that would equal to that number. And for 32, it would be 16 times 2 plus 3 to square root of, what makes 4 is 4 times 2 minus 4, and then 9 times 2. And the square root of, now 16 has a square root, which is 4, so then we would take that out and multiply it by 2. And the 4 here has a square root, which is 2, so then you take that one out as well. Minus 4. 9 has a square root, which is 3, so you take that out and multiply by 4. And now you want to multiply them, which is 8 square root 2 plus 6 square root 2 minus 12 square root 2. And since they all have the same square root, you can combine like terms, and you add 8 and 6, which will give you 8, 19, 14 square root of 2 minus 12 square root of 2, and that you would be left with 2 square root of 2, and that would be your final answer after you combine all the like terms.